Hello everyone. Today we are going to discuss about the chemical plant design. This is mostly the final year projects for the chemical engineers when they pursue their BTECs. So in this series, or we can say in this project, we are going to learn about how to develop a chemical process for a production of dipropylene glycol. And the agenda of this series will be discussion on uses, properties and storage of the dipropylene glycol production, selection of chemical reaction to produce dipropylene glycol, produce a flow sheet for the chemical reaction, find out parameters to operate various flow sheets objects. So basically, here we are discussing how to produce dipropylene glycol, what is the uses of dipropylene glycol, what is its properties, how to store the dipropylene glycol, and then we go for the chemical reaction that we are going to choose for our project to develop a process which will produce dipropylene glycol, and then we will produce a flow sheet for that reaction, how that reaction will be carried out in the reactor and how the products and the reactant will be separated out. And we will also find the parameters like pressure, temperatures, number of stages for distillation column, heat exchangers, area, and other properties to optimize the flow sheet and produce the dipropylene glycol. So basically, here we will discuss about all the things that you need to make your final year project a good project. So, and finally, we'll discuss about the cost and profits. Then now the next question comes: why we choose dipropylene glycol? So we choose the dipropylene glycol because the uses of dipropylene glycol, personal care and cosmetics. It is highly its ability to dissolve fragrance and attract moisture, make it valuable in perfumes. Plasticizer, DPG improves flexibility and reduce cracking in plastics. Food additive, it is used as a food additive in some countries. And the properties of DPG, mostly if you consider the physical and chemical properties of dipropylene glycol, we summarize in this table. So this table you basically requires when you go do calculations about the dipropylene glycol production flow sheets. So the boiling point at 1 atm to 32 degrees centigrade, we suggest that it will be in liquid form at a room temperature, and the melting temperature is minus 73 degrees centigrade, or at minus 73 centigrade it will freezes. Density, it is heavier than water because its density is 1024 gram per centimeter cube, while water is 1000. And the viscosity, it's viscosity and solubility in water is, it is miscible in water in all proportion, ethanol. So you can see we summarize all the physical properties that are required, because you require solubility when you design the separation process, because you might use these one of these solvents, so there are a lot of possibilities. So these properties you basically require to develop a process flow sheet. And similarly, when we produce the dipropylene glycol, it is essential to store it. So for the storage of dipropylene glycol, we know the safety diamond, it is relatively a safe uh, chemical. And for the storage condition, the temperature which is most critical, because if you not maintain the correct temperature, there is a chances of explosion in case of chemicals. So at ambient temperature, it is stored between 15 to 25 degrees centigrade. Maximum temperature you can store is 40 degrees centigrade, because higher temperature can produce the degradation of DPG to the PG, propylene glycol, and uh, it should be stored in the insulated tanks or temperature controlled storage. Similarly, for pressures, it should be stored at atmospheric pressures. We should avoid pressurizing DPG, because pressurizing it may cause other other safety hazards. If using nitrogen blanket, maintain a slight positive pressure to prevent air and moisture ingress. Because when we stores chemicals, if they are degraded by air, we use a nitrogen layer to prevent the air contact with those chemicals. Container material is important property, because it is like that. If you store HCl in a steel container, what will happen? One day HCl will corrode the steel and it will come out. Because HCl is corrosive to the metal. So if you store the HCl directly in a metal container, it will eat up the metal container during the course of storage, and it will leakage out of the material. So we use carbon steel, land steel, or stainless steel is the recommended. And the maximum avoid lined carbon steel for long-term storage due to potential discoloration and iron contamination. This is suggested because the DPG may can degrade your iron, so you should use the lined with the glass or other things. And stainless steel is preferred for long term storage and purity requirement. If you want to store it for long term, you should go for the stainless steel. Similarly, ventilation, which is also a required thing for the storage, keep container tightly closed in the well ventilated area. This is what is recommended, but you can also go for vent tanks to a safe location away from ignition sources. Light protection, store away from direct sunlight, so that you can use opaque containers are recommended for optimal protection. Shelf life maximum 1 year under proper storage condition. Depend on when you are stores a chemical, it comes with a shelf life. Suppose if you store a chemical who will degrade over a time, so then shelf life describe it likes us that for how much long you will have the DPG as a DPG, not as a DPG plus PG. So the shelf life is minimum of 1 year under proper storage condition. Incompatible materials, strong oxidizing agent, strong acids and bases you can't store with them. Segregate DPG from incompatible material to avoid hazardous reactions, because this will create a safety hazard in your plant. So today we are going to so let me summarize quickly what we have discussed. So this is the initial starting of our project. So we have discussed the properties of the DPG. We have discussed the uses of the DPG. We have discussed the safety diamond of the DPG, and we also discussed how to store the DPG. Because before we starting, it is really crucial that we should know about the chemical that we are gonna produce, so that it is just it may change our mind to produce that chemical, or it makes us cautious to selecting the materials of reactors, materials of heat exchangers, materials of uh, pipelines when we are designing a flow sheet, when we are designing a PNIDs for our chemical plant. So knowing these things beforehand really helpful. So here this is a overall summary of today's discussion. Hope we will next session we will discuss about, or next we will discuss about the chemical reaction that can produce DPG, and we will select a chemical reaction to produce the dipropylene glycol. Thanks.